guys, today we're going to do 13.5, the cosine function. The objectives is you will be able to graph and write cosine functions, and you will be able to solve trigonometric equations. The essential understanding. For each and every point along the unit circle, the radian measure of the arc has a corresponding cosine value. The colored bars in our next slide will represent the cosine values of the points on the circle translated onto the cosine graph. So as the terminal side of an angle rotates about the origin, beginning at 0 degrees, its cosine value on the unit circle decreases from 1 to -1, then increases back to 1. So here are our cosine values, and this is like the spaghetti, but now instead of measuring our y component, we would be measuring our x component. The cosine function y is equal to cosine of theta matches theta with the x coordinate of the point on the unit circle where the terminal side of the angle theta intersects the unit circle. The symmetry of the set of points x, y is equal to cosine sine of the angle on the unit circle guarantees that the graph of the sine and cosine are congruent translations of each other. So, what that means is cosine and sine have the same wave, they're just shifted. Interpreting a graph. What are the domain, period, range, and amplitude of the cosine function? So if I have y is equal to the cosine of theta, our domain is all real numbers because we have no restrictions. Our period is 2 pi, just like it is for sine. Our range is from -1 to 1. And the amplitude of the cosine function is 1. Examine the cycle of cosine function in the interval from 0 to 2 pi. Where in the cycle does the maximum value occur? And where does the minimum value occur? Where do the zeros occur? So, if we look at our cosine graph, we have maximum values at 0 and 2 pi. We have a minimum value at pi, and then we have zeros at pi over 2 and 3 pi over 2. So, the absolute value of A for y is equal to A cosine of B theta is our amplitude. B is the number of cycles from 0 to 2 pi. And 2 pi over B is the period of the function, just like it was for sine. Now, to graph cosine, we need our 5 points equally spaced, so we're going to still find our intervals. And the 5-point pattern is going to be A, and then we are going to go to our midline. Then we're going to go to opposite A or negative A, and then we're going to go back to our midline, and then we are going to go at A. Steps to graphing one more time. We have to draw our midline, find our amplitude, find our period, find our intervals, and then plot our points. A, midline, negative A, midline, A. Sketch one cycle of 1.5 cosine 2 theta. So I'm going to draw my coordinate plane, and I will start by finding the midline, which is at 0. Then my amplitude is 1.5. And my period is 2 pi over 2, which is pi. I'm going to take pi and make it into equal sections, so pi divided by 2, pi over 4, and 3 pi over 4. Now I'm going to graph. So instead of doing our sine wave, we have to start at our amplitude, or A, which is 1.5. Now I'm going to go down to my midline. Then I'm going to go to -1.5, back to my midline, back to A. So as you can see, our sine graph is just shifted over, and now we have cosine. And that's all.